Hi, I'm Max.
And I'm Carl, and today we'll be making a drive base. To get started, we're going to make a wheelbase, so here's what we're going to need.
So, to start, here are some of the pieces we need. First, we're going to need motors to actually spin the wheels. We're going to need wheels to translate that spinning of the motor into motion. We're going to need some gears to connect the wheels together. These axles go into both the gears and the wheels to help them spin. They also go into the motor. We're going to need one a little bit longer than the other two to actually go into the motor. Then we're going to need some collars to secure them. We're going to need some panels to provide stability and provide sort of a structure for our wheelbase. We're going to need some pegs just to attach them together. And then we also want some various connectors like these to attach these wheelbases together. So now let's get started into building. So we're going to start by attaching our wheelbases together, and I'm going to do it like this. So as you can see, this is a nice sturdy wheelbase with 4 points of connection, four pegs on all the corners to make it nice and sturdy so it doesn't want to fall apart. And as you can see, it has some points for connection to the back, on the back, and it has this which actually prevents it from tipping backwards, as it's almost like a stopper. So next, we're gonna put in some of the gears. So here we have the gears attached to the gear base. As you can see, 2 of them spin in the same directions, these two, the 2 on the sides, while the middle one spins in the opposite direction. That is because gears spin in opposite directions as the next one that they're touching. So 3 is the perfect amount, or any really odd number of gears is the perfect amount, as the end 2 will spin in the same direction, while the middle one will spin in the opposite direction. Now, a little bit on gear ratios. If I were to substitute this middle gear right here and spin that middle gear, have that middle gear being driven by the motor, if I were to substitute that middle gear with a smaller gear, so like with a gear like this, that would create a torque gear ratio, because as one rotation of this motor, which is fixed, spins this gear here, these gears on the side only spin a fraction of the way around. And you can calculate that fraction, but we're not going to go too far into that. However, that means if it's a small gear that's being driven by the motor to a big gear with a bigger gear with the wheel on it, that wheel is going to spin slower, but it's going to spin more powerfully. So those gear ratios are good if you want a really strong drive base to push another robot around. Or you want a really strong arm, for example, to lift up a heavy object. That's when you'd want a torque gear ratio. However, if I put a really big gear in this middle gear instead of this, and had this middle gear being driven by the motor, that would create a speed gear ratio. For example, when this gear would make 1 revolution, these smaller gears on the side would make more than 1 revolution. So the wheels would spin faster, but they'd spin less strong with less power. So again, this is good if you want a really fast robot, but that robot might not be able to push what you want it to push. So gear ratios are a trade-off. An even gear ratio like this is going to give you the biggest balance between speed and torque. And you can do a whole bunch of different things with gear ratios. But now I'm going to attach the wheels and the motor. I'm going to attach the motor, unlike I was talking about in the gear ratio one, to this final one, just because it's going to fit that way with the rest of this build. But you can attach this gear to any one, because these are all connected through this same gear channel. So let's get into it.
All right, now it's my turn. So now we're going to attach the motor and the wheels to the wheelbase. So here we are, we got the motor and wheels attached. If you hear that noise, that's how you know the motor's all connected. And now we just need to make another one, which I already did, so we're all good.
So the next step is to attach these 2 wheelbases. We had 4 points of contact for each wheelbase to be sort of connected together, but you want as many points of contact in between these wheelbases to make them super secure and super sturdy that is the main key factor to the success of your drive base. You want it to be as sturdy as possible. There's no going over the top, but there's so many different ways to do it. You can get creative here. There's so many points of attachment where you can attach this wheelbase to this wheelbase and make it as sturdy as possible. So let's show you one way of doing that. So I attached these two drive bases through a plate here and a plate on the back. This is nice and sturdy. And to that, using these sort of L connectors, I attach the brain, which is the main hub of the robot. And once we have the brain on, the final step is to attach the brain to the motors to get them spinning. Ideally, you want to attach the motors to 1 and 6 because those are easily testable with the driver control program. So we want to take these wires, plug them into the motors, just like this, and then attach them to ports 1 and 6. So I'm just going to attach this one to port 1, and then I'll attach the other one to port 6, and then we have a fully functioning drive base. And as you can see, this is the normal drive base, which is a 1-to-1 gear ratio, but you guys are going to be building ones with different gear ratios. Building ones with speed gear ratios, torque gear ratios. You can even build one by, instead of using gears, using sprockets and tank treads, you can build sort of a tank drive base. And for those of you who want to go above and beyond, we'll have you figure these ones out, but you can try to build an H drive, which uses omni wheels and a wheel in the center here that can control it going side to side. So I can't wait to see what you guys have to build, and good luck on your first challenge.